Good morning, students. Welcome to the lecture series of Formal Language and Automata Theory. In today's lecture, I'm going to discuss about a finite state machine with an output. Previously, we have discussed about a finite automata that have only two output, either 0 and 1. Whether it is going to accept the string, then the output will be 1. If it is not going to accept the string, then the output is 0. But in today's lecture, we will discuss about a finite automata with an output. Here, the output depends on the present state and the present input. Sometimes the output depends only on the present state. So here, on giving some input, we will move to the next stage and we will also have some output. There are two types of finite automata with a output. They are Mealy and Murray machine. In today's lecture, I will discuss Murray machine in detail. In the coming lecture, I will discuss about a Mealy machine and how to convert a Mealy machine to a Murray machine and a Murray machine to a Mealy machine. So first, let's discuss about a finite automata with a output. Sometimes a finite automata may have output corresponding to each transition. इससे पहले we have learned about a finite automata which is defined by a how many tuple? There are 5 tuple and that tuple are capital Q, summation, delta, Q0 and your initial state and final state. These are the 5 tuple. And when we have a finite automata with a output, यहाँ पर क्या होगा कि इनिशियली आप किसी प्रेजेंट स्टेट में हैं, आपने इनपुट दिया, you have moved to the next state or you remain at the same state, but there is some output with each transition. There are two types of finite state machine with a output. They are Mealy machine and a Murray machine. Let's see this. Let's see that a finite automata with a output is of two types, the Mealy machine and the Murray machine. Now I will define what is a Murray machine. A Murray machine is defined by a 6 tuple and these tuple are Q, summation, transition, X and Q0. First of all, Q. What is Q? Q is a finite set of state. कितने number of state मेरे machine में होंगे हैं, that is your Q. And summation, how many input alphabet, how many alphabets are there. And here we have O. O stand for the output alphabet. Here in a finite state machine with an output, we have input alphabet as well as the output alphabet. And delta represents the transition function. It means on giving some input to the present state, we will reach to the other state. And X is your output function that maps Q into O. And Q0 is the initial state. A finite automata with the output, we don't have any final state. Here we have a output function, transition function, initial state, input alphabet and the set of state. Now let's see one example of a Murray machine. A Murray machine is a finite state machine where the output depends only on the present state. It means कि if on giving some input we are moving to the next state and there is some associated output, तो output सिर्फ present state पे ही depend करेगा, वहाँ पे वो input पे depend नहीं करेगा. तो let's see if we have a Murray machine, then M, how many states are there? A, B, C, D. We have a input alphabet 0, 1. How many output are there? X1, X2, X3 are the output. We have a transition function. X is your output function and A is my initial state. So this is our Murray machine. How we represent a Murray machine? Let's see. This is a table, transition table of the Murray machine. First we will have a present state. We will have a next state which and a output. Here the output depends only on the present state. In the next state, on giving input 0 where we are reaching and on giving input 1 where we are reaching. मुरे मशीन में क्या है कि जब आप ट्रांजिशन टेबल बनाओगे तब हमारे पास प्रेजेंट स्टेट रहेगा, नेक्स्ट स्टेट रहेगा. नेक्स्ट स्टेट में हमारे पास दो इनपुट है, तो वी हैव टू शो कि इस दोनों इनपुट में अगर आप वी हैव दो इनपुट है, एक 0 है और एक 1 है, तो 0 में देने से आप कौन से नेक्स्ट स्टेट में जा रहे हैं एंड 1 में देने से आप कौन से नेक्स्ट स्टेट में जा रहे हैं. दैट इज रिप्रेजेंटेड हियर. And finally we have a output in the transition table. So what we will learn from this Murray machine that there are 4 state A, B, C, D. 4 state है, दो input है 0 and 1 and we have a 3 output x1, x2 and x3 और A मेरा initial state है. मैंने बताया कि Murray machine में कोई हमारा final state हम नहीं represent करते हैं. So let's see. Initially we are in the present state A and A में अगर आप input 0 देते हैं तो you reach to the state B and on giving input 1 you reach to the state C and the output associated with this present state A is your x2. Similarly अगर आप present state B में हैं तो 0 देने से आप B में ही रहते हो और 1 देने से आप D में पहुंचते हैं and the output is your x1. C में 0 देने से C and 1 देने से D and the output associated with the present state C is your x2 and D state में present state D में अगर आप 0 देते हो तो आप पहुंचते हो D पर ही और अगर आप 1 देते हो तो आप पहुंचते हो D पर ही. एंड आउटपुट क्या है इसके साथ आउटपुट है x3. तो हम कैसे मुरे मशीन को अगर उसे मुझे ट्रांजिशन डायग्राम बनाना होगा तो हाउ वी विल ड्रॉ द ट्रांजिशन डायग्राम ऑफ द मुरे मशीन. सो वी विल हैव initial state that is your A. Now on giving 0, wait, let me clear the diagram. I will draw it once again. We have initial state A, then on giving 0 we reach to B, on giving 1 we reach to C. Now let's B में अगर आप 0 देते हैं तो आप कहाँ पहुँचते हो? B में ही पहुँचते हो और अगर आप 1 देते हो तो you reach to D. Now similarly C में देखो, C में 0 देने से we reach to C itself and on giving 1 we reach to D and D में 0 and 1 देने से हम D पर ही रहते हैं. Either we will give if we will give 0 we will reach to D, if we will give 1 we will reach to D. And now we have a associated output with each state. ये state को हम कहाँ, यहाँ पे मुरे मशीन में जो हमारा आउटपुट है वो प्रेजेंट स्टेट पे डिपेंड करता है. तो हाउ वी विल रिप्रेजेंट A के साथ कौन सा आउटपुट